Hello everyone, I'm Ravi Verma, co-founder and CTO of IMESH. In today's session, we'll be going through implementing Envoy-based API gateway into Kubernetes. So we'll deploy it. After that, we'll go through a demo in which we'll be seeing few of the core features of Envoy gateway. So let's go ahead and so in today's agenda, we'll be going through API gateway, like what is API gateway, a brief intro to that. And after that, we'll go for a deployment. And after that, it will be a demo. So let's start with what is an API gateway. So API gateway is a kind of front door to all microservices based architectures in which like we provide a single entry point for the outside world to enter into that our cluster, which is having multiple microservices, like thousands of microservices. So the benefit it brings is like we have only one endpoint for the client. It enters into that one and it manages internally. It distributes traffic to all other microservices, takes the response back, aggregates that, and send back to the client. So client need not to know like how many microservices are running inside the cluster. So that simplifies a lot. Plus, it brings a security because only one point is exposed to outer world and that is secured, so that like any other microservices inside that, no one will have a direct entry to those microservices. So it brings security as well. So few of the, so we can see like in the diagram as well. So internet traffic and API gateway is a front door, like it is an entry point for the cluster. And it manages all internally, all microservices. It forwards the request, takes back the response, and again forwards back to the internet traffic, like basically the client. Now we see like these are the basic core features or the common features of any API gateway which we have in the market. So like it works as a reverse proxy. It does HTTP routing. It does rewrite of the URL, then traffic splitting, TLS termination, rate limiting, authentication also it provides at the barrier level. Like at the first level, it only creates a barrier, like no one else other than the authorized user will be able to enter into the cluster. So that also it is provided. Like I was mentioning in the like security, it brings the security as well. Then redirecting, like internally, if some URL are there that need to be redirected to the another upstream cluster, that also it can be done. Then request response header manipulation, we can do TLS pass through, TCP routing, UDP routing, even gRPC routing, we can do it. So these are the kind of common, like bare minimum features if any API gateway provides. Okay, so now we today we'll be going through the installation and demo of Envoy gateway. So this is a little bit of intro to Envoy API based gateway. So based on well proven, we already know like Envoy proxy are getting used at many places, and this API gateway is based on that Envoy proxy. So it's already well proven, it's very secure, so we can use it in production. Based on a Kubernetes gateway API specification, it means it is a generalized form, like API gateway is a specification in which it brings a simplicity for all Kubernetes users, basically, so that it specializes and it defines a particular rule, so that it doesn't create any problem or a confusion for the end users. Because if something is specified or like a specification has been created, it is easier for any user to maintain it, basically. Otherwise, if any like if like suppose 10 API gateways are there and they are following their own structure, so if people want to try another one, it will be very difficult because each and everyone will have their own different set of structures, and it will be difficult for one to understand and remember all those structures. So that's where it is very efficient and beneficial. It is very good for north-south traffic handling. And the more advanced feature is like Istio. We know Istio service mesh is all over the world, and Istio service mesh uses internally, it uses Envoy proxy as a core, like in a data plane, and the same core Envoy proxy is used here as well. So definitely it is the same core. It brings the same functionality and it brings the same security. Then comes like it is, that's why it is very easy to integrate with Istio as well. Like if in future, if someone wants to go for the Istio service mesh, it will be very easier for the migration or the integration with Istio service mesh if they start with gateway. And the last but not the least is like Istio is going to make its gateway, like currently Istio implements their own gateway, gateway implementation, but they are bringing that gateway implementation to follow the specification of gateway API. It means again, it will follow the same standards and it will be very easier to understand. Like if one knows one part, then it will be very easier to maintain and understand the other part as well. So it means unified experience will be there. Okay, so now we'll head towards installing Envoy API gateway. So for that, we need to apply this, like we can go to directly to cluster and apply this command. So at the time of this video, 0.3.0 has been released. It is still in alpha. Active developments are going on, but it is having a basic features which can be used as a API gateway. So we will be going through that. Okay, so without wasting any much time, let's go and install it. For that, we need to go kubectl. Okay, so before going there, let's check if we have anything. Kubectl get ns. Okay, so it is clean. We don't have any Envoy gateway installed here, so we'll install it. Kubectl apply. So it does two things. It installs the all CRDs specification, like CRDs which is created by Gateway API. Plus it installs CRDs of Envoy API Gateway. Plus it creates a controller of Envoy API Gateway. So all these things, when we apply this one, all those things will be done. Yeah, so it will be done. So it's done now. We can verify that with again kubectl get ns. So we'll have a namespace now. So Envoy gateway system we have and gateway system. So gateway system is having gateway API specification, like all CRDs it's here in this one, and all, anything related to that to handle that part, basically controller and all. And Envoy gateway system is having Envoy API gateway controller and all related things inside that. Fine. So now we are ready for the demo, but before we go for a demo, let's try to understand a bit of a structure, basically how and what all the things, parts of the Envoy API gateway. So for that, let me open my whiteboard. Okay. Okay, so we have few parts here. So structure is like we have a gateway class. So I'll be explaining what is that. So we have gateway class. Then we have gateway. After that, we have HTTP route. So this HTTP route, we can have any number. So the structure is gateway uses basically which gateway class to be used. and HTTP route like references. Basically, it references which gateway to be used, and gateway reference which gateway class to be used. So here gateway class is nothing but implementation of a particular controller. So it can be, basically it is based on the cloud provider, and because it does something like when we create a gateway, it internally creates a load balancer as well. So definitely it's based on the service provider, like which service provider, and based on that it sends the request to create load balancer and all to allow the outside traffic inside the controller, basically the cluster. So this is based on mainly majorly, or like it depends on the cloud provider. This one we can have any like one, and which can refer to any number of, not any, like we can have as many as gateway we want, but one gateway will point to any one of the class, and basically it points to which controller it is handling that particular gateway. HTTP route, we can have any number of HTTP routes, and there also we specify which gateway to it refers. So it can be like this basically. So all these are HTTP routes. So communication like HTTP routes follow like which gateway it is using, and the gateway which class it is implementing that particular implementation. Here we can think of this one as these two. We'll see, like it is having little similarity to ingress, but it is not same as that. So we can think gateway as a ingress, but in ingress what we see, we can apply rules also, but here to make it more flexible and easy to manage, it is broken into two parts: gateway, where we specify which class to be used, and the HTTP route, so that it like we can handle routes here at one place, and gateway at one place. To bring it more flexibility, it is done. So we'll see the similar structure during our implementation. Let's go and check our deployment. We'll create and we'll follow the same rule. Let me bring my Visual Studio Code. Okay, so we are ready. So first, with what we saw, we need to create a gateway class. So basically it's a implementation as we discussed. So let's create that. So let's name it demo gateway class.yaml. So we have already installed CRDs, so we should be able to access it. The gateway APIs. So for that, we need to write API version gateway dot networking dot Kubernetes, basically KS dot io v1 beta 1. Then we need to mention kind. It's a normal, like the way we create any Kubernetes resource. So we have gateway class. Now we'll have metadata. Here we need to give name. We can give any name for that. Let's give a name as for now today, Envoy gateway. And we need to give specification. Specification, we need to specify which controller is handling basically all this gateway. So for this controller, we can give controller name, and we have gateway dot, because we are using Envoy based, so we can. For any other gateways, like the controller will be different. So Envoy proxy.io gateway class controller. Yeah, so this is our gateway class done. After that, we'll create a gateway object. So for that, let's go and create another file. Let's name it demo gateway.yaml. For this, we need to write API version. Again, gateway networking beta 1. Then we have kind, it's gateway. Then we have metadata. So we can give any name. Let's give the same name, Envoy gateway. For that, we need to specify spec. For that, now, as we saw in the picture, we need to mention like which gateway class to be used here. Basically, who is like this gateway is handled or to which gateway class it references. So for that, we need to give like who is handling that. So gateway class name. So if you remember, we have in ingress, we have a ingress class name basically. So we mentioned there as well, like ingress who is handling that ingress part. So it's similar to that. So we can visualize it. It's a kind of ingress part. So as I was mentioning, it is like broken into two parts. So we'll see. The first part is here when we specify which controller, basically which class it is referencing or which class it is handling. So we can, as we gave that name as NY gateway, we need to specify the name here. Then we have listeners. Okay, and we need to give name. So let's give HTTP. We need to give protocol. So it's HTTP. And we need to specify port. So 80, default port, we are using it. So these two are done. Let's deploy it. After that, we'll be creating our application, and to access that application, we'll be creating HTTP route. So before that, let's create this one. Deploy. So we have two files. Let's deploy it. kubectl. So let's deploy gateway class. V1 beta 1. 1 minute. Maybe something is wrong. Some typo mistake. Let me check. API version gateway networking beta 1. And we have gateway class metadata, my proxy controller name maybe here. Controller. Sorry, yeah, here. Controller name basically is typo mistake. Fine, let's apply. Fine, so it's done. Now let's apply the gateway. Oh, again typo looks like. Let's see. Okay, what's the error? Cannot handle as a gateway studio coding errors. Gateway class name. Okay, let's check if something is wrong. Gateway metadata, Envoy gateway class name. Okay, again, spelling mistake, gateway. Fine. We can check also. So we can check kubectl, get gateway or GTW we can do. So we can check and we can see we got the IP address. So this is a public IP address we'll be using to access our application. So as I was mentioning, when we deploy, that time internally, basically it goes to cloud provider. It asks that to create a load balancer, and it is the IP of the load balancer basically. So we can check it is having it creates a service also. So for that, what we can do, get, let's check service in gateway system basically. Envoy system. So we can see here it created Envoy default gateway, which is of type load balancer. So it requests cloud provider to create a load balancer and attach that IP. So basically we get IP from there. Fine, we are good with that. So now let's start with our application. So let's create one application of any Nginx type. Let's create that like what we are using it in the past. So let's write demo deployment. Let's give a name Nginx. YAML. So we know that API version we need to give apps v1. After that we need to give kind deployment. So these things are already we have seen. So it's not nothing new here, but yeah, we need to type it. So let's give a name as maybe Nginx or web server. Let's give web server Nginx. We can give specification after that. Clause 1, then we need to give selector match labels. So let's give app web server for now. Web server as a match label. And then we need to specify template for this template. Let's not try to make any, like try to minimize our typos. Otherwise it gives error. So it's YAML we know. Okay, labels, and we need to specify same label here. So let's give the same. And then we need to specify the pod, basically specification, container and all. So we need to specify spec, containers, we need to specify image. So let's give image as Nginx. So it will pull the latest Nginx image. We can specify image pull policy. So that is not mandatory field, but yeah, we can specify that. Like if this image is not available, then it will pull. Or even we can put it always. Always means it will, whenever this pod is created, it will pull the image no matter what. So let's keep it present. Then we can give name. So we can give maybe web server nginx or nginx web server. Ports we need to specify. Say that we need to specify container port basically. 80 default port. We'll keep it. Fine. So this is done. Deployment is created. Now let's go and create a service basically for this so that we can communicate to this. For that, let's give a demo. Let's give a name service. Fine. So API version we need to specify as v1. Kind is service. We know normal it's cluster service. Cluster IP service basically. Metadata we can give a name. So let's give a name as web server backend or maybe, yeah, web backend. And then spec we need to give. So spec we know we need to provide selector like to which pod, set of pods it need to be applied. So we need to give the same app what we had given. So it applies to these all these pods. After that we need to specify ports. So port we can keep it same 80, not to worry. And then we need to specify target port. So target port. Again, keep it same. We are ready for the deployment of the application. After this, we need to create our HTTP route. So before that, it will not be able to access it. Let's deploy it. Try to access, but it won't work from the outside. So let's deploy first our deployment application basically. Demo deployment, let's do it. Then let's deploy service as well. Fine, so we can check as everything is there in default namespace here, our application. So we can check it, get pods. So pod is running, we can check service as well. We have service also running, so we can see it. So web backend, we have already it's listening. But if we go to that particular IP, we won't be able to access it because we have still the linkage missing of from HTTP route to service. That is not there. So let's test it first. Let's go here. Yeah, so we don't have linkage. So like after HTTP route, basically HTTP route links that to microservices. So if we go here to our diagram, if we see here we have here microservices will be sitting at this level. And these will be linking. So this linking is basically missing here. So that linking we need to create. So let's go ahead and create that. So let's give as the name again demo HTTP route. So for that, we need to specify again API version, which is gateway beta 1. kind is HTTP route. Metadata name we can give any name. So let's give us maybe HTTP backend we can give name. After that we need to give specify specification. So let's go ahead. So now this is the interesting part. We need to see where and all referencing we are doing. So as I was mentioning in the diagram, we need to link it to our gateway. Like who is the gateway who is going to handle this part? Like to which gateway this particular HTTP route is linked. For that we need to specify parent reference, basically reps. And here we need to give a name like which. So we had given Envoy gateway. So we need to use that name here. After we are good for applying our rules. So here we need to apply rules. So we can see like in case of ingress, we had that one in the same. So that gateway API is more powerful than ingress. Ingress is having limitations. To basically overcome that limitation, we have now gateway APIs into picture. And those advanced topics we'll be discussing in our future sessions. So nothing to worry, we'll cover everything. Here we need to give backend reference. Basically like once if the request is coming here, where it should go. So like who is the upstream. So for that we need to specify backend reference and we need to specify matches also. So let's specify matches. So if nothing is there, it's a default match it will take. So we specify matches like which path and all it should go. So let's give it matches and we need to give path. And we need to specify which, like what is the type of the path. So we can give this kind for now, it's a prefix. Prefix, basically path prefix. Like slash something which we give so that it will match with that. And if it is matching one of them, then it will route here. And then value, what should be the value of that path prefix. So for now, let's give it slash miss root path. So whenever we hit that particular IP, we don't give anything after that, it will hit this path. We'll be adding few others, we'll be seeing that. So this is done. So where? So now we specified, okay, these are the things, like these are the matches, okay, oh, if this matches, now what? So definitely we need to specify where that request would be forwarded. So for that, we need to specify our like service. So for that, we specify as backend refs. So backend reference basically. So again, let's not make any typos, try to at least. Backend reference we need to provide. So here we can give our name. So here we can specify kind, group. So currently the default kind is service. So that's fine. Optional, will not give it. So we can give any name. So the name of the service we need to give. So which service we had given. So here, this is the name, we need to take that. And we need to specify port, basically on which port is it is listening. So port, it was listening on 80. Now we are good. So once we deploy this one, we should be able to access our Nginx page. So let's go ahead and try to deploy. If everything goes fine, we should be able to access the page. Just okay. So let's go and deploy first, and after that we can access it. kubectl. Yeah. So we created our HTTP route, and that also we can access from here. kubectl get HTTP route. So we can check it. We have created this one. So let's go ahead and try to access that. Perfect. So now we created the linking and now we are able to access the page. So it means request went to our HTTP route like that, that linkage which it was missing. Now we created that. So now we are able to access the page. Let's add another route and try how it works. So we'll be adding one more route with another service and we'll test that one. So, okay, let's go ahead. Okay, so before adding new route, let's add another service so that we can forward that request to that service and we should be able to test it. So let's create another deployment. And let's use the image of eco server. So I'm giving a name as eco server. Okay, let's name it eco server. Let's add that. And here, let's use the image of Cilium eco server. So, Cilium eco server. Fine. And for that, we need to create another service to communicate to this. So let's create that as well. Eco server. Okay, let's name it as the backend eco server. And we need to apply that label to this one so that it can point to this pod. So label is web server eco server. Let's verify it quickly. Web server eco server. Fine. Let's go ahead and deploy this. So go to terminal, kubectl, apply demo eco server. Let's deploy it. And let's deploy our service as well. But we know even after deploying the service, we will not be able to access it. So we need to create a route. So let's go ahead and create a route. So what we can do, either we can add the route here, new rules here, or we can create another file as well. So that's the advantage of creating route. So it is giving control to developers, which like whoever developers working on a particular specific service, they can create their own route and they can maintain it themselves. So let's create, it's additive in nature. Either we can create it multiple in a single route, which can become very big if we have a very large number of microservices, which will be difficult sometimes to manage it. So we can break it like different files we can create, and those can point to a specific service. So it is easier to maintain in that case. Yeah, it is having a few difficulties as well. Difficulties in the sense if we miss out with another, like if we override the path, then it will be kind of not working as expected. So that definitely we need to make sure that overlapping of the paths are not happening. Okay, so let's go ahead and create new route for our new service. So I'm giving a name as eco service. Okay, and here we can maybe give a path as 1, for example, to test another path. And we can give eco server backend here. And let's name it as eco server backend eco server, so that it doesn't overlap or basically overwrites the existing one. So we need to change the name. Okay. Now let's go ahead and deploy. And after that, we should be able to test with /1 path. kubectl demo HTTP route echo server. Fine. So now let's go ahead and access. So this is our root path. We have already checked it's working. Now if we go with 1, we should be able to open echo server path. Yeah, here, yep, it's working. So we can see here it is coming, the request is coming from echo server, web server, what the host name we had given. Here we have information related to that particular pod. We can verify that. And we have a couple of like options or basically the informations available here, get method and all. So real path, we can check it here, it's 1. So we tested another path, like another route. We added root route, then we have added another route. What we can do, even we can add more routes. Like when we saw it is with 1 rule here, let's add 1 more rule and we should be able to get going that as well. So let's add it here. And I'm changing path to push 2. But still I'm using the older one, so not an issue. It will go with this, like it will go to the same server, but we will be able to see the path is different here. So if I go again directly here, it should be giving error because you don't have that route. So let's go ahead and deploy our echo service again. Fine. Now let's refresh it. Fine, perfect. It's working. So now we can see that another path is coming as a 2. It means we are able to route different endpoints through different services. So that way we tested our API gateway as a like HTTP routing we saw. Now next we will be seeing our basically what to say, traffic splitting. So let's check that how it works. So for that we can do in the single reference, like we in that case in the same path we need to give different backend reference so that it can split. So like we can traffic splitting like canary and all, we can do it. So let's try that now. Okay, so here we have 2 different paths. Now we'll test that with 1 application here only, like 1 route, and we'll try to split in 2. So for that, to identify whether it is splitting, the traffic is splitting happening or not, let's create another application of the route like echo server as with the different name so that it creates another pod and we should be able to check. So let's create another deployment of echo server. I'm giving the name as suppose v2. v2. So let's change the name here as well. v2, let's add it everywhere. v2. Image and all, we're keeping it same. Here, let's give its name as v2. Fine. Fine. To access this deployment pod, basically we need to create another service. Let's go ahead and create that as well. So now let's create v2. And as we have given v2, so we need to add v2 here as well. So now with this service, we should be able to access this deployment. So let's go ahead, deploy that, and after that, we'll modify our route to test our traffic splitting. So kubectl deploy-f demo echo server v2. Let's deploy. We'll make note of the deployment, basically the pod ID, so that we can verify it quickly. Service echo server v2. Fine. Let's check So now we can see we are having two different versions of Eco server running here, one running with Nginx, which is a root path. So now we'll be checking this one, the traffic splitting between these two Eco servers. So for that, what we need to do, we need to modify our route basically. So what we can do, let's check this path one with traffic splitting. So for that, what we need to do, we need to add basically another backend reference here so that it can split them, like basically it can split the task between those two. So for that, let's add it. Another backend reference, 1 minute, copy it, sorry. Just 80 only, now it's, so now we have two. So let's, this one is pointed to back server 1, here we can give it to 2. So that it goes to second server. So now if we deploy, we should be by, if we give like this, it will be splitting like 50-50, it will be going to both the servers, both the upstreams basically, that we can test it quickly. So let's go ahead, deploy and test it quickly. Just 1 minute. Let me bring my terminal. So let's redeploy this route. Fine. We can see here we have two different pods ID. We can see one is Q starting with Q at the end, Q2 GSC here FV. So we should be able to test that. So let's go to our one because we have added two destinations there, basically two backend like upstream services. So we need to go there, test it. So here we can check that ID, basically the pod ID we can verify. So here we have host name. Let's verify with F. Here we can see. And if I refresh, it's so it should be changing. We can check it here. Have a look at this part, this area. I'm refreshing and then it is switching. Like basically it is sending request to one service, like 50-50% each time. So that way it is splitting the request to both of the endpoints basically. So here we can check. Now, if we want to have a canary deployment kind of thing, if you want to configure for that, what we can give a wait so that, and later we can simply move the traffic, make the traffic more for the different services. So for that, we use wait configuration. So if we check it here, suppose I'm making it 2, and here I'm 1, it means it should behave like it should go to this one service 66% of the time, and here it should come as a like 33% of the time. It means if we refresh 3 times, 2 times it should go to the first one, and then 1 time it should go to the second one. So for that, let's verify our ID quickly. So V2 is having starting at the at the end it is having it is starting with F, and the normal one, it is version 1 is starting with Q. So that let's remember that. And let's deploy and test it. Fine. So let's refresh. So it is F. Okay. So now it is pointing to version 1. So I refresh twice. So it is still pointing the same. Now it is going to the second one. So we can see. And here also we can check like if it is sending the same or not. So this request ID is getting changed. So it is going to the second one. Now first one, this one, So verify this is queue, and now I'm refreshing. It is still. So first time I refreshed, second time refresh, then third time it's going. So we can check that. Yeah. So it is splitting the traffic basically between these two. So this weight need not to be, summation of this one need not to be always like 10 or 100 or anything. It can be any number, and it splits basically, it decides based on the summation of this one. So it will, what it does, it adds this one and then divides by total, try and finds which one should forward the request. So that way it does that. Fine. So now we tested traffic splitting as well. Now the next part is for the today's demo is URL rewrite. So URL rewrite, sometimes it is like, it can be used in various scenarios. So few of the scenario could be like, we have already given a endpoint to a customer, but but that new service is still not yet ready. So what we need to do, we need to point it to the older service. So that can be done like until the time it is ready. That's one of the use case we can use it. Even we can forward the request based on, like, we could have scenarios like based on some headers value, header set in the HTTP, that can be used to decide which route to take. So in that case also, either we can take the different route, or we can rewrite the URL to point to some other location. So like there are many scenarios. So these are a couple of scenarios. For that, what we do, we apply a filter. So as we know, in case of Envoy, we use a different filter chains, and that based on that particular filter which we apply, it can take a decision where it need to go, or it can terminate, or it can even forward the request. So that is similar kind of concept here. We will be using filters to basically modify that path, URL path basically. So for that, what we need to do, we can modify the same one only. Okay, so this one we tested with the traffic splitting. Let's test this one too. Modify this path to test our URL rewrite. For that, we need to add one filter here, so that we need to add it. So for that, I need to come here. I need to add filters. And in that, we need to specify what is the type of the filter. So that is URL rewrite. Rewrite. Like as I mentioned, the URL rewrites can be used at the different scenarios. We have a lot of scenarios to be used. Few of them we discussed, and we'll test that. So for again, we need to give URL rewrite, like we need to specify that what is the configuration to be used. So URL rewrite, and here we need to specify what we are trying to do now. So what we can do, we are writing path, basically path rewrite we are trying. So for that, we need to give path, and we need to specify type. What is the type? Like it can either replace the full path, or it can replace the prefix, or like that both can be done. Either prefix can be rewritten, or the complete path can be rewritten. So let's try with first is prefix path. So replace prefix match. And we need to give what to be replaced, basically, to with what. So replace prefix match. This is smaller. And we can give which, like when we hit 2, it will be actually redirected. Basically, the path will be rewritten to something else. And so that upstream will get a new path of that. So we can try with 2 if we are. So let's write replace. Let's name it prefix replace. So if any request going with 2 / something or 2, which will be replaced, the path will be replaced with prefix replace. So let's deploy this and try it out. Fine. Deployed. Let's go to our path to test it, which is 2. So here we can check. So path here. So we can check here. So here we are giving 2, but that is getting modified to prefix replace. So your request is going actually like this to upstream server. So upstream server can take a decision based on the new path, basically what is the path endpoint it's coming. Okay. So that is like prefix path. Okay, prefix path also we can try. So suppose 2, and we have given some ID here. Some ID is equal to maybe something like this, anything we can give 1, 2, 3. So we can check here. With 2 it is giving, and now it is getting replaced. So this 2 is getting replaced with prefix replace, and we are having a new endpoint basically. So that URL is getting rewritten. If we want to replace the complete thing that we have is, so for that we need to use another filter type. Basically the type need to be changed. So that is replace full path. So this one prefix match, here it is. Full path. Full path replace new path. Okay, let's go ahead, deploy it. So 1 minute. Sorry. Replace full path. Yes, so here this one also it need to be, because it's a mismatch, we need to give replace full path here. Fine, let's go ahead, deploy it. Now we can try our request. So we can check this 2 is now, or 2 is now getting replaced, or basically the full path is getting changed, this one here. So I can give another path / something, but it will be replaced with the complete full path. Fine, perfect. So what we saw, we have covered our 3 scenarios basically today. We saw HTTP routing, HTTP URL rewriting, and then traffic splitting. So we saw all these 3. For the other features, we'll be coming with future sessions in which we'll be discussing more features and how to use it with the help of Envoy API gateway. That's all for today. If you have any question at any point of time, please feel free to contact us at contact@imesh.ai. Thank you.